Okay, so just as an intro to the recording, we're going to do a logarithmic regression. We have some data that's provided. If they want you to do a log regression on a test, well, I mean, obviously in this unit we're doing log regressions, right? Because it's the logarithmic unit. But if they want you to do a logarithmic regression on the test, then they're going to say run a logarithmic regression. Okay, they won't expect you to sort of guess what type of regression to use. So we have some data, which is the age of the tree in years, 1. And we have 11 years worth of data, and we've got some heights for the tree. So they all started out at 6 feet. Okay, then we have 9.5 feet. 13, 15, 16.5, 17.5, 18.5, 19.5, 19.7, and 19.8. And we know generally that trees don't keep getting bigger forever, right? Or that their growth rate slows down, or the trees out there could be a couple hundred feet high. Right? I mean, there are limiting factors to tree growth. So are these trees probably still growing in height? Yeah, but at not as great a rate as they would have when they were young trees, right? The same as you guys. I mean, when you're young, you grow at a pretty fast rate, and then it slows down, and then you basically stop growing. Okay? So that happens, and what we want to look at is a model for this growth. Okay, and one way to do that, of course, is to enter the data into the calculator. So I'm going to turn this on. I'm going to go second plus number 4, clear all lists, and hit enter. So I do that anytime I'm entering a list of data, right? On the exam or on the diploma exam, you may have to do 3 or 4 regressions. You want to clear out the lists in between. We'll go to Stat, Edit, and we're going to enter the numbers 1 through 11. Okay, so we'll do those. 1. And then we'll go over here and we will enter our height in feet. Okay, and then we'll see what we're dealing with. So we've got 6, 9.5, and be careful as you enter numbers that they're right, or double check them. Slide this over. Oops, that was 18.5. 19 for 8. 19.5. 19.7. So we can see that the growth is starting to level off, and enter this correctly, 19.8. Okay, so I have all my data in L1 and L2, the number of years in L1, the growth in L2. Let's set ourselves an appropriate window and just take a look at the data itself, right? So, what would be a good window for this? Do we want -10? Yeah, so let's start with 0, right? So 0, even though we don't have data for that. And we want to go as high as, maybe we want to go out a ways, right? So beyond 11, say 15 for now. We can always change that later. So let's go 0 to 15. By ones, that'll give us 15 ticks. You can see about 20 ticks on the on any of the axes. So I'm trying to figure out how big is this thing, and my scale should be such that I can see maybe about 20 ticks. Otherwise, it just gets a little fuzzy, right? You can't see each of the individuals. Minimum. 0 is reasonable. We know it's 6, but it doesn't hurt to have 0 in there. And maximum. Okay, we're looking at 20 here. Sure, let's just say 20 and see what happens. And by ones for the scale, because that'll give us 20 ticks, which again is reasonable and it's seeable. We put the data in, so I'm going to go second y equals, go into the stat plot. So second function y equals, go into stat plot, turn the plot on. And generally that's about all we have to do, right? We have our data is in L1 and L2, which is what it's going to use. It'll use this for the mark, and it's a scatter plot. That's what it defaults to. So a scatter plot with the x data in L1, y data in L2, and that mark. And we can now hit graph, and we can see our data. And if we remember back a week or so ago, we'll remember that, hey, that looks a bit like a logarithmic, right? It's going up and then leveling off. Okay, so that could be logarithmic data, right? I mean, it could be quadratic as well, but do we think that this is then gonna, that the trees are gonna start shrinking? No, right? Okay, so we know, yeah, this particular data, and you have to put it in the context of the problem, right? I mean, the trees aren't gonna shrink, not gonna grow and then shrink, so it's not quadratic, okay? And so we'll run a log regression. So we go to stat, edit, to calc, and actually going down to the bottom of the list, and it's ln reg, okay? So it's a logarithmic regression, but we're using ln, we're using the natural logarithm. That's how this calculator works. It's regressions if you're going to do logarithmic. So we got ln reg. Now if you got a TI-83, you're just looking at ln reg. If you've got the 84, then it's telling you my x list is L1, my y list is L2. Store regression equation. Okay, so if you're looking at a TI-83, you do ln reg, and now you're going to go to vars and over to y vars and hit enter twice. And that's just telling it where to store the regression equation, right? Put it into y1. And then I can go down to calculate, or you'll just hit enter. So on the 83, you've got ln reg followed by y1. Right, vars, y vars, enter, enter. You go to calc. And ln reg, so you go to vars, over to y vars, hit enter twice. Now press enter. Okay, so are we all seeing these numbers? Okay, so that's a good thing. So let's copy that down. Now you notice what form it's in, right? It's a plus b times ln x. Okay, so the x stays. We want to rewrite that, but with an a and a b. Okay, and let's round to, let's say 3 decimal places. So we'll go y is equal to 6.099 plus 6.108x, or sorry, ln x. Okay, so I can write that out here, yeah. So y is equal to 6.099 plus 6.108 ln x. Okay, so we have a logarithmic, when we run a logarithmic regression, we get a natural log. Right? We're using ln as the base of the log. Okay, we don't get a base 10 log. All right, so we did a stat plot. We plotted the stat plot, looked at it, said, looks like it's logarithmic. We get the equation of the logarithmic. So now we can say, well, let's take a look at the whole thing. So if I now hit graph, it's now going to graph the scatter plot, and it's going to graph the line of best fit. Okay, does that line fit reasonably well? Yeah, it's going through, if not all the points, at least the boxes upon which the points are, right? I mean, very rarely do we get a perfect fit. Okay, very rarely do we get a perfect fit. We could turn the diagnostics on and then look at we're going to give you an r squared value and an r value to tell you how well it's fitting. But we can see from here that's a pretty decent fit. So now we can use it to answer some questions, right? Like, we can interpolate looking within the data set. So what was the average height of the trees at 1.5 years of age? So let's go in here. So interpolation. What was the average. Now remember, these are all averages we're looking at, right? I mean, they measure all the trees and average them together to get that 9.5, the 13, etc. What was the average height of the trees? At 1.5 years of age. Okay, so what do we do to get that? Which one is age? X's or Y's? X's. So what do I want? I want an X value of 1.5. How do I get that? Okay, second calc, value, X, 1.5. And we get 8.56 feet. Right, or 8.6 feet, I guess, to the nearest tenth of a foot. Let's call it 8.6 feet. Right, so we did, and we get 8.6 feet. What else could we ask? Well, we could ask when they're 20 years old, what will the height be? So let me just go to a new page here. This would be extrapolation, right? Going outside of the data. Our data only goes for 11 years. So what will the height of the tree at 20 years of age? Okay, what do we do on our calculator then? If I want to put in 20 years of age. Years? What do we do? Shall I pause this to take out the awkward silence? Yes? Yeah, so same deal, right? We have an X value, we want to figure out the Y value. So we go second calc, value, 20, right? And of course it explodes. And the reason it does that is, what do we need to do? Yeah, we need to adjust our window. So I can just say quit. We need to change our window so that it goes out to at least 20, right? Otherwise, that's just a function. The calculator's just messed up, right? I think it should be able to do it, but so let's go to 25. While we're at it, we might want to increase the Y max because it was sort of starting to head off anyways. So maybe change that. Let's go take this up to 30 and maybe go by 2s. So now I can graph that. We can see, yeah, okay, you know, those trees are still going to keep growing. Okay, so now we go second calc, value, 20, and we got 24.4. Okay, so 24.4. Let's just bring the calculator back and we can see that point. And last thing that we do sometimes is we ask, if the average height of the tree is 10 feet, then what age would the tree be? So if the average, let's change that, 10 is boring. If the average height of the tree what's a number that really wasn't in the table? Well, actually 10 wasn't, but let's go with 14. Yeah, 14 sounds good. If the average height of the tree is 14 feet, then how old is the tree? Okay, back to the calculator. So what do we have to do to find out the age of the tree when the height is 14? Okay, so our height is our Y values, right? The equation is the model height, right? It's modeling the height for us. We want to get a height of 14, so we go into y2, put in a 14, graph that, and then what? Intersect, right? So second calc, intersect, and the way I do an intersect is just to move to about the point of intersection. And hit enter 3 times. And we get 3.6 years of age, right? So when the tree is 3.6 years old. Okay, then our model predicts. Remember, the model is simply predicting, right? Based upon data that we collected and a prediction, the model is predicting that the tree would be 3.6 years old. Okay? So, that's a logarithmic regression example. There's one in the book as well. Why don't we work through the book one together? So it's on page 461. Page 461. And we can see the example deals with a flash on a digital camera. And in order to operate, it has to charge up. You always hear them sort of whining after you take the picture, and you can hear the flash. If you stick it close to your ear, you can hear it, because it's powering up the flash again. And the way the flash works, it's got a capacitor which holds a charge. It'll dump that charge into the flash, which causes the flash to go off. Your camera can then say, okay, I've got enough light, and cut the flash off at a certain point, right? If I'm taking a close-up picture of somebody using a flash, I don't need the same amount of light that I would need if they're here in front of me as opposed to back there, right? I'm going to need more power in the flash to light up that area. So that's the flash duration, right? How long the flash lasts, it's going to use a certain percentage of the charge. And that's what we're looking at in this table here, right? It's a percentage of the charge. So let's put this data into our calculator. So I'm just going to go back to zoom 6. I'm going to go back to a standard zoom. I'm going to go to y equals. I'm going to try and go to y equals, and I'm going to clear stuff out of there. Okay, and I'm going to go second plus 4, clear all lists. Right, so I'm going to start with a clean slate. I've cleared out y1. I've set the window back to the standard window, and I've cleared out my data. Okay, so now we can go in, enter the information out of the table. So percent charge, 100, 90.26, 73.9. You don't need the trailing 0 on it, right? It won't make any difference. 60.51, 49.54, and 40.56. 56, 6. Enter. Okay, and then my L2. So the time, you have 100% charge if the flash hasn't fired, right? That's the time of 0. So is the time L1 or is the time L2? So in this case, and what we'll find a lot with the logarithmic regression is that the time might actually be the y value. Okay, so the time depends on the percent charge. Okay, so the time in this case depends on how much of the charge was used. So 0.01, what do we got? 1, 3, 5, 7, and 9. Yeah, 0.03, 0.05, 0.07, 0.09. Okay, so double check your values, right, anytime you do regression, especially on a test, and especially if it's numeric response. If it's multiple choice, you'll just end up likely with an answer that isn't one of the answers, and then you can go, oh, okay, I made a mistake. If it's numeric response, you're going to get an answer, and it'll just be wrong. Okay, and you're getting 12 numeric response on the diploma, right? That's a good chunk of that. Okay, we're going to go to stat, we're going to calc, we're going up to an LN reg. Again, if you're using this, store regression equation. So if you have yours, just it'll say ln reg. You don't need L1 and L2. You can put them in. You can go L1 comma L2, but calculator defaults to using list 1 and list 2 if you don't say otherwise. And I want to store it, so vars over to y vars, enter twice, store it into y1, and hit calculate. Okay, and the equation we get is y equals, so 0.45, all right, so we go to 3 decimals, let's go to 4 decimals, 0.4597. Plus, in this case, sorry, minus 4.0998, 0.0998 ln x. Okay, and then make sure that matches up. 0.4597, 0.0998 ln x. If we want to see what that looks like, both scatter plot, because we entered some data. Okay, so we need a window, and we know that our x values are going to go from 0 to 100, because the x's are the charge, and let's say we go by tens. Okay, so the charge can go from 100% down to nothing. Right? And the time values, in other words, the amount of time that the charge will fire, can go, well, we're looking at 0.09. So the next bigger number than that would be like 0.1. So maybe let's go from 0 to 1 by 0.1s. Okay, and well, we can adjust this, right? We'll graph it and we'll see what it looks like. So I'm going to hit graph. There's our points, and there's our graph. Okay, and we actually do have a point up at 100, 0. We can't really see that, so I can adjust the window a little bit. Make the x's go from -1 to 100. Make the y's maybe go up above 100, because I'm not seeing that point that's at 0, 100, or the 0.01. Let's go minus. Whoops. -10. And the y value is 0, so 96.26. Percent charge. Okay, so say again, dealing with a logarithmic function, and what questions did they want answered? Entered the data in my graph calculator, created a scatter plot, which we have, although our y values are kind of spread out. So let's take our y window down. Instead of 0 to 1, let's go 0 to 0.1, or 0.05s. There we go. We'll get a bit better spread there. Okay, so we can see a little bit better that with 100%, it's 0, and it's kind of climbing up that way, in a sense. So this is your percent charge. So the more your charge, the less duration you've used, and this is the duration of the flash. Location of, okay, what do they ask for? What did they ask? Start scatter plot, that did that, determine a logarithmic model. Use your to determine the t.5 flash, the 50% time. So I want x to be 50%. Whoops, so we got a graph, second calc value, 50. So when x is 50%, then our duration, our flash would have gone off for 0.07 seconds. Okay, so 50%. 0.07 seconds. Okay, rounding to the nearest hundredth. And what else? They asked, oh, there's a your turn at the bottom of 462, the 10%. So second calc value, 10%. Remember, our x's are percents. Gave us 0.22, 0.23, so 10%. Okay, so if you use most of the charge, you're getting the flash going off for like 0.2 of a second, right? It's got a hole, which means the camera's telling it that, you know, the subject you're eliminating is further away. You've got to provide more light, right, to light the subject up. And let's throw one of our own in and just ask if the flash duration if the flash duration were 0.035 seconds, then what would the percent charge be? So in this case, we have to go into y equals, because this time we're looking for a duration, and the y values are durations, for 0.035, and hit graph, and then find the intersect, right? In order to find the x value, which would be the percent charge. So second calc, intersect. And get close, 1, 2, 3. And we would have 70%. Okay, so 70.3%. Okay, so we're taking data, we're entering it into L1, L2, we're running a ln reg, logarithmic regression, which is number 9, ln reg. We're getting the regression equation in the form number plus number L times ln of x, right? So we're using the natural log, which is a base E log. It's what you're going to see in any textbooks from this point forward, right? If you're doing any courses in natural sciences or anything like that, that's what you're going to see is ln. You're going to see a lot of that used as the base of the log and not base 10. Base 10 is handy if you're just working stuff out on the calculator, right? Because we got that long key. There's another example in here. You can look at yourself. I don't think we feel like entering this data in, right? No, you know. But it deals with using logarithm to solve a problem algebraically. So caffeine is found in coffee tea, and it works on what level of caffeine will be in your body after a certain amount of time. So the rate at which you excrete the caffeine. And so, you know, you can look through this example and just sort of read through it. And what they did was enter that data and then do a logarithmic regression and answer some questions about that. Key ideas on 466. Logarithmic function may be a good model for a set of data if the points on a scatter plot form an increasing or decreasing curve where the domain is restricted to the set of positive real numbers. Right? Remember, with logs, it has to be positive real numbers. Need to know the general form of logarithmic regression model. They give you that. How your calculator is going to put it out to you in the form a plus b ln x. And then using that log curve to predict values, right? Either given an x value, get a y value, or given a y value, find a particular x value. They give another little blurb on the bottom of 466, which is sound level, decibel level, and intensity of sound. Okay, well, sorry, that's the questions, right? So away you go. So decibels, sound levels are logarithmic, earthquakes are as well, and there's some stuff on that in there. Okay, so a bunch of questions to do. Do enough that you feel comfortable doing one of these regressions on Thursday, right? Because that's when the test is. You're going to get a couple of regressions on Thursday. So make sure that you feel comfortable doing them, right? You know which keys to hit. You know that you're doing an LN reg, right, number 9, okay, and how to enter the data. And that time may not necessarily be the X value, right? The time might be the Y value, okay? And you shouldn't feel bad because of that.